What's going on, everybody? It's Mr. Gust, and I am in a physics classroom doing chemistry. Call me crazy, but there's no chemicals, so we're all being safe. Today, we're talking about Keq expressions and solving for unknown concentrations. Keq is doing some math stuff with chemicals that are in equilibrium. Not chemicals that haven't reached equilibrium yet, but chemicals that have had enough time to react and have, in fact, achieved a dynamic equilibrium. We're going to do some math practice thinking about Keq expressions, solving for unknowns, including concentrations at equilibrium and equilibrium constants at equilibrium. Have I said at equilibrium enough? We're not doing not equilibrium, we're doing equilibrium. Here we go. I've got this reaction. This is a hydrogen gas and a nitrogen gas reacting together in a synthesis reaction of ammonia, and this is an equilibrium process. The first thing I want to do is make sure my equation is balanced. And by looking at it right now, I can clearly see, yikes, it is not balanced. So let's go ahead and balance this equation. I have got two nitrogens in my reactants and only one over here. I'm going to go ahead and throw a coefficient of 2 out front of that. When I do that, my nitrogens are balanced, my hydrogens are not. I've got 6 hydrogen particles over there, only 2 over here. I've got to throw a 3 out front. Once I've done this, now my equation is balanced, and now I can go ahead and write my Keq expression. Let's remember, our Keq expression are products over reactants raised to the proper coefficients, raised to the proper exponents, and those exponents are coefficients when I'm talking about an equilibrium system. So just as a reminder, it is products over reactants, all raised to their appropriate coefficients. Let's go ahead and make it more specific. This is my general formula. Let's make it more specific. Let's go ahead and say my product is NH3, but it's the concentration of that, raised to its exponent, which is 2. So it's concentration of NH3 squared. In the denominator, I'm going to end up with the concentration of N2. Its exponent or coefficient is 1. Multiplied, not added. A lot of you want to add these concentrations together, but it's still a rate law. It's just a rate law. It's a quotient or ratio of rate laws. We're multiplying concentrations together, not adding them. So N2's concentration multiplied by hydrogen's concentration, but this is raised to the power of 3, or cubed, so that we have our Keq expression. Now, at equilibrium, I'm given some conditions. I am told that at equilibrium, I have these concentrations of chemicals. Therefore, I should be able to find the unknown. And the unknown in this question is Keq. Let's go ahead and solve for Keq. Let's start with our equation right here. I'm going to bring it down by plugging in some variables. NH3 has an equilibrium concentration of 0.005 molar. But again, it should be squared, so I do that. In the denominator, the concentration of nitrogen is 0.03. There is no exponent here, so I'm going to leave that guy alone. H2 has an equilibrium concentration of 0.02 molar, and it should be cubed. Your job is to evaluate this expression. Grab your calculators, do it at home, because you're not going to be very good at this unless you do this yourself. Don't write down your answer from mine work. Do it yourself. I'll write it down, show you how I do it. Take 10 seconds and plug it in. Let's go! I end up with, if I did this right, 0.005 squared divided by 0.03. That's not squared. This should be cubed. It's cubed. There we go. 104. I get an answer of 104.7. Indicating to me, because that number is bigger than 1, indicating to me that the numerator or the products are favored. This NH3 thing is favored in this reaction. Now, how did I do it? Let's look closely at my work. If I look really closely at my calculator, here is exactly what I typed in. I have parentheses, 0.005 squared. I keep that whole numerator in parentheses. Make sure that that calculator knows this is a number. And then I divide it, and look what I did. I divided with 2 parentheses in the way. This is saying, hey, the whole denominator is in a parenthesis, and then every number in the denominator is. So 0.03 multiplied by 0.02 cubed, and then I close that parenthesis and I close off the numerator, saying, hey, there's a numerator, there's a denominator, and I want to divide those two. When I do that, 104.7, the products are favored in this reaction. Problem solved. Let's go to number 2. Number 2, I see a new equilibrium. This equilibrium is an equilibrium between SO2 and oxygen gas. I'm looking for here the concentration of SO3 at equilibrium. What is that concentration? This is what I'm trying to solve for. So first things first, let's write our Keq expression. Keq, products over reactants, that's SO3 cubed divided by SO2 squared times O2. Let's start plugging some numbers, and this marker's not doing so hot. I'm going to change it out. Keq, plugging in some numbers. 85 is the Keq, is equal to the unknown number. Let's call it x cubed divided by whatever SO2 is. SO2 is 0.05 molar, but it needs to be squared. Multiplied by whatever O2 is, and O2 happens to be 0.05 molar also. It's not squared because guess what? It's not squared in the Keq expression. This is it. Now I've got to do some algebra. Some algebra would say, and my math teacher would say, let's divide this by 1. Let's cross multiply. I end up with 85 times this denominator, 0.05 molar, squared times 0.05 molar. That's equal to whatever x is cubed. So you'll have to take the cube root of that. When I take the cube root of that, let's see what I get. I'm grabbing my calculator. You should too. Solve for x. No denominator this time, which is nice. 85 times 0.05. And I got to make sure that I take the cubed root of that. How do I take the cubed root of an answer? I have to take the cubed root of an answer by doing this. Let's go back to my calculator. I made a quick little trick. I did 85 times 0.05 cubed because I got 0.05 squared times 0.05. That's 0.05 cubed. So I have that. When I get that answer, that 0.2, or I'm sorry, I get the answer here, I'm left with 0.01, whatever that is. But that's not my answer. That's my answer cubed. So what do I have to do? I have to hit the button. I got to hit 3 first. So now I hit, whoa, let's make sure I'm down here. I've got to hit 3 to make sure I'm taking the cube root of something. And then I want to hit this x square root button. That tells me I'm going to take the cubed root of whatever number is there. And then I'm going to input my answer. And when I do that, it spits out 0.22 as an answer. So what is the concentration at this equilibrium? 0.22 molar is the concentration of X, or what did I call it before? It's the concentration of SO3 at equilibrium. SO3 at equilibrium, it is the largest concentration. What do you know? That Keq is indicating that products are favored because that number is very, very large. These are just 2 examples of how I can use Keq expressions to determine whether or not products or reactants are favored at equilibrium, and how I can use Keq expressions to predict what concentrations are present at equilibrium for either products or reactants. If you got questions, drop in the comments, send me an email, or as always, ask me in class. Until next time, see ya!